Awesome. Hey, so my name's Jeremy. I'm one of the co-founders of a little company called Firetail. We've got about 20 minutes for today's presentation. I apologize in advance. We probably won't have time for Q&A right here, but I'll be right there afterwards. And then also, I'll breathe this across the other side. More than happy to continue the conversation there. So today what I want to talk about is something that I've come up with called the 5 layers of AI security. And I think a lot of us were struggling in our organizations today to understand all the AI adoption that's happening and what are the risks associated with it. So I tried to build a model to help think through the different aspects of that risk and the different kind of flavors of risk that might be present in the organizations. So a little bit about us and a little bit about myself before we get started. Like I said, I'm one of the co-founders of Firetail. This is a little bit about our team. You might recognize one of our advisors. He's been a keynote speaker here many years. Those are our investors. And something that I'm very proud of for the team over here is that we've been a finalist in a number of competitions. Our innovation in the AI security space has been pretty widely recognized. Apologizes for the glitches on the slide advancement there. We earlier this week won a CISO pitch competition. We are helping to solve one of the most challenging and pressing problems across organizations today. And that is, how do security teams enable the secure adoption of AI within their organizations? I think it's pretty widely recognized at this point that saying no to AI is not really a reality. It's not really a possible thing at this point. I did recently speak to a former CISO of a regional bank who tried to make the decision to block all AI usage inside the organization, and he found that to be a career-limiting move on his part. So what does that mean? It means AI is definitely coming. It is coming to your organization. And so what you as a security professional might need to think about is, how do you get ahead of this problem? And how do you enable adoption in a secure manner where you can manage the risk everywhere along the way? This is not a theoretical problem. This is a real problem. We have already seen many real-world scenarios of organizations that have had real data breaches, some with massive scale, some with large-scale impact in terms of the number of records breached, in terms of the impact and the reputational damage to the organization. And we're talking about, known global brands that have had issues, including the Cybersecurity and Infrastructure Security Agency of the United States of America, where the interim director was found to have uploaded sensitive documents to public ChatGPT. Public, not enterprise, public ChatGPT. And so you ask yourself the question, if organizations with this level of skill, resource, and availability of any tooling that they want are having problems, the chances are your organizations might also have problems at some point in the future. Gartner is forecasting that most of the data breaches that are going to happen in this space are because of improper usage. Well, what does improper usage look like? That's one of the things that we're going to talk about in today's model. One of the other things I'd like to highlight on the Firetail website, if you scroll all the way down to the footer, and I apologize that the link is buried in the footer, you'll find something called the AI Breach Tracker. We've been collecting and correlating all of the AI security incidents that we see that get disclosed publicly. As I'm sure many of you know, there's kind of a general rule of thumb in our industry that for every publicly disclosed breach, there's 9 to 10 more that go undisclosed. So you can kind of take this number and multiply by 10. Or a factor of 10 to kind of get a sense of how big the problem is. Another interesting thing, we overlaid our data set with the data set that goes all the way back to the 1980s around breaches and events in the adoption of AI. And what you really see here is that, in the 2010s with the first wave of, let's say, machine learning, we saw a couple of incidents a year here and there, never really made it above kind of the 50 mark. And then lo and behold, we get to 2021 and we see this kind of exponential hockey stick up into the right curve that every startup, myself included, would love to be able to show our board of directors and our investors. Look, we've got the hockey stick growth. Awesome. Except that in this case, this is AI security incidents. So this is a real problem facing our entire industry today. This is not a theoretical problem. This is reality. So what does security mean in the age of AI? So I mentioned at the beginning, this talk is mostly about trying to give you a thought model or a kind of an exercise framework and 5 questions that you can ask yourself to understand what's going on inside our organization and how should we think about the risk and how should we think about responding to the risk. And my talk was inspired by something that Jensen Huang, the CEO of NVIDIA, came up with. I don't know how many of you might have seen this. AI is a 5-layer cake. And to the NVIDIAs of the world, I think that is largely true. And you think about what 5 layers need to go into it. Well, AI is notoriously power consuming. So obviously energy and electrical infrastructure is super important in there. Second, you need the chips to run it. A little bit of a self-serving comment from a company like NVIDIA, who has a $1 trillion valuation on the back of selling the chips to run AI systems, right? But you get into the next layer is the infrastructure. Where are those chips going to run? And then only then do you even get into the models and to the applications. And that's a really compelling vision of how AI actually works. But I would argue that that's not the reality for how most of us are going to be using AI in our own organizations. Most of us don't have these 9-figure budgets and the access to or the desire to build all the infrastructure needed. I challenge you to go out and buy all the NVIDIA chips and GPUs that you need to go build your own data center to run this stuff right now. And I will tell you that you are likely to be outbid by the hyperscalers if you even get into a conversation to try to buy some of this stuff. Not easy to come by right now. This model has inspired a lot of derivative 5-layer models, and I've looked at a couple of those, and I kind of say, well, are there any of those that I can think about as a way to frame the problem for the security professional who's trying to understand how to manage this in their organization? I found this one, and it's kind of like, well, okay, there's the general AI models. Think of this as the foundation models, like your Anthropic Claude family of models. Or maybe you do some specific training, you do RAG, you do a training database and a set of exercises, etc. Or maybe you go hyper local, you hear about SLMs, small language models that are more task specific and very focused. Maybe use a lot of vector embeddings to get to exactly the use cases that you need to target. And then you get to the OS and API layers and the application layers. And I kind of looked at these two and I thought a couple things. Number one is these top 2 layers are the layers that the vast majority of us are actually going to interact with. So let's focus our thinking there. And the second thing is, well, are you really going to do all this? That's not the reality that I see from most organizations that I talk to. Most organizations are focused on a foundation model, 1 or 2, or maybe 3 or 4 in their organization. Yes, targeted, limited use case, but most are not going to the layer of SLMs or very, very specifically trained models around this. So I started asking myself the question of like, okay, if we're really only focused on the application, API layers, etc., does this remind me of any other technology transformation waves that I've lived through in my career going back to the late 90s? And the one that really came to mind is the rise of cloud computing. Cloud computing was kind of a fundamental shift in the way most of us thought about infrastructure and securing that infrastructure. We went from having to build and run our own data centers and hardware and, secure every layer of that to just being focused on, in the case of cloud, the OS layers and above. And Werner, one of the things that he talks about is you can launch an LLM-powered business, an LLM-powered application today with the same ease that you could launch a business on the cloud. He says 2006. I would argue that cloud didn't really get to that level of maturity where you could really stand up something to maybe more like 2010, 2011, that kind of time frame when EC2 came in a number of flavors and you could just kind of carve stuff out really, really quickly. There we go. There's our little menu. Awesome. And along with that, though, what did we learn out of that wave of cloud computing and the security model of the cloud? In case it's already popping to your mind, I will say it out loud. It is the shared responsibility model. I am sure that everyone in this room has seen a version of this chart, 20, 100, 200 times. And we think about the different types of shared responsibility models for kind of infrastructure as a service, platform as a service, and software as a service. And this is actually very, very parallel to the LLM consumption that we're seeing today. You can think of different flavors of it right now where, infrastructure as a service is kind of your private models. So in the case of the cloud providers, this is your Amazon SageMaker. This is, where you're going to take GPU-powered virtual machines, install your own models, do all your own training, apply your own guardrails, etc. You're going to own it from the operating system level or above. But then there's also simplified versions of that we would think of as platform as a service. So this is your Amazon Bedrock, your Azure AI Foundry, your Google Vertex service. And then you also have your software as a service. This is your consumer-facing applications, your ChatGPT, your Cursor, your Windsurf, right? Where you're actually getting something that is already kind of use case purpose-built, narrowly trained for a set of uses, etc. What's the common thread in all of these things? Well, I would say there's kind of two common threads. Number one is, if you think about the shared responsibility model, the cloud providers always talk about they're responsible for the security of the cloud, and you're responsible for the security in the cloud, right? They give you a secure platform to build on. How you use it is up to you. That's also true of these models of LLM consumption. They give you the infrastructure, they give you access to the models, the compute, the GPU-powered instances, etc. You are responsible for your usage of those platforms in those environments. Couple other things that go along with it. You think about your actual usage, that is your responsibility. So the data in, data out is always your responsibility. Your organization's consumption of any of these models is yours. What's different is now we've introduced this model layer. And the model layer introduces a new set of risks that we've never seen before. Prior to the LLM-powered offerings, everything was deterministic. Everything was binary, ones and zeros. It works exactly the way you expect it to work. While it's still binary, it's no longer deterministic. That introduces some risk at this model layer that you can't mitigate for, except in very limited ways. We're going to talk about a little bit in the model. So that's where my thinking went around that. And I said, okay, great. So we understand what the customer responsibility is in any consumption model around this. Where does that leave us? Well, we've seen this model before. We've got some new wrinkles. We understand the architecture. We understand the overall division of responsibilities. But yet we have, and then we've got this defined accountability. So just as I said, you're always responsible for your consumption in the cloud. Same is true. You are always responsible for your consumption of the LLM service. Just this morning, I recorded this week's episode of This Week in AI Security, 15-minute weekly podcast, shameless little plug. One of the stories from this week is that a British Columbia court in Canada found Air Canada liable for their customer service chatbot providing a discount to a customer. Air Canada tried to contest it, said, well, the chatbot should never have offered that discount. And the court said, no, it's your chatbot. You are liable for it. So remember, the accountability is always yours. You are responsible for your secure consumption in these environments. These new AI wrinkles of the non-deterministic thing, you have to account for them. The model providers will not take responsibility for unexpected circumstances. It is your job to control for that. So, as I said, you don't control the models, you don't control the outputs, but you do own the accountability. So I've come up with this kind of mental model of thinking about the challenge, 5 layers of AI security. So what are these layers and how do I think about it? First is the model layer. One of the things that we've understood over at Firetail, we've done vulnerability scanning of most of the foundational frontier models on the top providers. So most of the models coming from Anthropic, from OpenAI, from Cohere, Mistral, the popular providers, and even some of the ones that are maybe a little bit lesser used, Qwen, DeepSeek, etc. What we've mapped is we found that there are 25 primary categories of vulnerabilities that almost every LLM has. The only difference is that they have them in different flavors, and certain models have higher vulnerability rates in category 1 versus category 24, and so on. Again, you're responsible for what model choice you make and how you consume it, and you inherit some of those vulnerabilities based on the model choice that you make. If you're ever curious to learn more about it, please talk to me. We can show you the risk map that we've developed around this. It's everything from those that are more vulnerable to base 64 encoded prompt injection to those that are more vulnerable to role-playing scenarios that will bypass their ethical guardrails and give you instructions for building a bomb or writing a phishing email to get your grandmother's password, right? So that's the model layer. Second is the shadow layer. This is very parallel to kind of the shadow IT problem that we faced, but the difference that I give you in the AI world is if you think about previous waves of shadow IT, let's say like SaaS adoption inside your organization, well, that usually came from one particular business function. Sales wanted Salesforce.com, marketing wanted Pardot, Marketo, whatever the case may be. The challenge with AI is that everybody wants it. There are use cases in finance, HR, software development, sales, marketing, everywhere across the organization. Your developers want to build on it, etc. So understanding the usage, the category of usage, the type of usage is the next layer that you have to account for. Third is the integration layer. One of the things that we've understood in analyzing about 150 different engines and how people consume them, all AI usage happens over APIs, whether indirect or direct. So whether you're making API calls knowingly or whether you're consuming a service that then makes the API calls on your behalf. So we've understood that that is actually a primary attack surface. And in analyzing AI security breaches over the past yearish, we've realized that is the attack surface of choice for adversaries who are looking to exploit organizations that are building on top of this. Next is the data layer. You understand who's using what models where, you understand how it's integrated, what of your data is going into those interactions. Whether that is an employee uploading a spreadsheet of PII or HR information or corporate secrets, or whether that is a developer who is integrating with your CRM system and pulling customer records out. Understanding what data is being used is the next key challenge. And last, but definitely not least, is the identity layer. And by the way, you could argue that, my layers were out of order for your organization. That's fine. I don't really, the point is not the order of the layers. The point is that these are the 5 layers to kind of think about from my model around it. Understanding who is using it. Is it Jeremy in his web browser? Or is it Jeremy, the software developer who integrated an Anthropic Claude model on Amazon Bedrock with a code repo and now has that app in production? Who is using it? And similarly, if I did build that application, what permissions have been given? What identity has been given to that application to run? So once you kind of have the answer to these questions, we know the risk profile of the model, we know the tools being used, we understand the use cases, we know the data that we're using, and we know who's using it. Now we can make informed decisions about what is right or not right for our organization. So these are kind of the 5 questions that we think about in helping organizations secure their adoption of AI right now. So our vision, in case you're curious, with our last couple of minutes here, is to help you say yes to this by giving you answers to those 5 questions. So at Firetail, we cover kind of the 2 sides of the coin, everything from your employee usage, Jeremy and his web browser, to Joe, the developer who's integrating an application. We collect data from code, cloud, workforce environments, and different data sources, provide continuous discovery, detection and response, centralized log collection. We give you a risk model of the different foundational models. And we also give you the ability to then write policies and rules around what is right or not right for your company in AI adoption. So those are, again, the 5 layers. I hope you found that interesting. Of course, you're more than welcome to the slides. If you scan that code, we will actually get you a copy of the slides delivered to your inbox. I actually have about a minute left, but I'll leave that up for a minute and I'll just kind of remind you, I'm not going to take questions live here, but I will be talking right there afterwards. And then please come over to the booth and have a chat. And I think that's it. Thank you very much.